Good, good afternoon, everyone. I'm Marek Konarzewski, and this is a great pleasure to introduce to you our speakers of today, Professor Tim Lenton, a renowned geologist and a wonderful person working on the concept of Gaia, but first and foremost, a direct collaborator with Bruno Latour, who will be the lead person, unfortunately absent today, and Adam Izdebski, a great friend of ours, a historian, but also, well, historian turned a naturalist, biologist, and you name it, really a person of many talents. And having you both here is a wonderful opportunity because of already mentioned Bruno Latour and his actor network theory as a possible bridge between different disciplines, in particular between humanities, social scientists, and natural sciences. And this is a really fitting time because unfortunately Bruno passed away last year, and this is with a great regret that I acknowledge his absence. But his legacy is with us, and we hope that you will give us a good reasons why his legacy will be with us for a very, very long time. So with no further ado, if I could ask Tim to start our seminar. So Tim, the floor is yours, please.
Thanks, Marek. Thanks for inviting me. I couldn't say no to the opportunity to speak in an event kind of honoring Bruno, who meant a lot to me. Our collaboration meant a huge amount to me. So I thought I'd talk a tiny bit about how Bruno changed kind of my view and maybe our view on Gaia, on the living Earth system, or how we should look at it, which is why I'm going to call it Gaia as seen from within, rather than Gaia as seen from above. Mm-hmm. So I probably first came across Bruno through this book that he wrote, Facing Gaia, 8 lectures on the new climatic regime. I can't remember, but I think it was pretty sure it was him that got in touch with me. But he really was wrestling with the politics of Gaia and the climate change situation and ecological crisis we were in, obviously, in this book. And what is striking about Bruno's perspective is just how he looked at this almost planetary scale phenomenon of life from the bottom up, whereas Lovelock and others could be argued, at least in the popular imagination, to have come to Gaia and the Gaia hypothesis from looking at the Earth from the top down. Actually, Lovelock has his kind of epiphany and his vision of the Earth as a self-regulating system before this photograph is taken. And if Bruno was still alive today, he'd be laughing at me for showing this photo, because he would berate me for saying that photographs like this one from the early space program are kind of the view from nowhere, in the sense that hardly anybody has the privilege to see the Earth from the outside in its totality. And he would also argue that it kind of misleads our view of how we should see or understand both the system, the living system Gaia, and our place in it. But Lovelock and Margulis in their Gaia hypothesis are kind of making a top-down statement that life is somehow involved collectively in atmospheric homeostasis by and for the biosphere. And it's kind of, the popular portrayal is that Lovelock came to that vision and that view through his involvement in the early space program, from really employed by NASA to help them in their search for whether there was life on Mars, the red planet here. And Lovelock took a very top-down view of that quest, because he basically contested the proposition that most of the people working on the program had, which was that they would design some sensors to go on the Mars landers to see if there was life in the soil or something. Lovelock instead reasons from above or from the top down. He's as well as from the bottom up, you might say, because he took Erwin Schrödinger's ideas about how to think about life from a physics perspective as a kind of thermodynamic anomaly in the universe. Living things have to maintain their highly ordered state. They have to take in matter and free energy and degrade them essentially and pump out different waste products. But if you take that recognition to its logical extension, if life is present on a planetary scale, it's going to change the chemical composition of the atmosphere of the planet it lives on. And then this might show up, was Lovelock's realization in 1965 or before, that would show up as a chemical thermodynamic disequilibrium up at the planetary scale in the composition of the atmosphere of a planet. And indeed, in the late 60s, observations were possible to look at the thermodynamic state of the atmosphere of Mars and Venus, as well as the Earth. I'm excited that someone's managing to zoom bomb and scribble on my screen. It's certainly not me putting the scribbles on. Anyway, I'll carry on. So, yeah, this is just plots of the composition of the atmospheres of Earth, Mars, and Venus to bring home the point that Lovelock's idea of Gaia starts with the recognition that life is creating and maintaining an extraordinary chemical cocktail in the atmosphere of the Earth with an extreme thermodynamic disequilibrium. You have highly reactive mix of gases like hydrogen and methane together with loads of oxygen that just couldn't exist by chance, that's for sure, and it has to be actively maintained by life. And then Lovelock, in contrast, Mars and Venus have essentially got dead atmospheres, and they kind of tell you there's no life there. But furthermore, Lovelock knew even in the mid-60s that this was a fairly stable atmospheric composition over geologic periods of time, and that demanded an explanation. And therein began his hypothesis that life is actively regulating the composition of the atmosphere, which he extended further to the climate. But as it's portrayed, a kind of, well, there's some bottom-up thinking there, but it's also a kind of top-down view of a Gaia at a planetary scale. That said, and as Bruno would remind us, Lovelock was also very much an empiricist and a bottom-up scientist, and someone who'd built a career on building exquisitely sensitive detectors like this one, famous electron capture detector, and then using those instruments to detect new gases, biogenic gases that alter the composition of the whole atmosphere, but are present at tiny trace concentrations. Here in some photos from Lovelock's home at the time in Wiltshire in the what is this? This is from the 60s, I think. What does it say? Yeah. This is Jim actually taking photographs, looking at trying to understand why their sky is clear on some days and full of pollution haze on the other, relating this to wind direction, relating this to human activities elsewhere in Europe, creating a pollution haze, so on and so forth. It's what Latour would say is sort of seeing Gaia from the bottom up. It's seeing the actions of individual organisms and their forming networks and collectives, exchanging gases, and this then spreading out from local scales to larger space and time scales. And that's another shot from Lovelock's history book. This is Lovelock with his daughter Christine measuring the composition of the atmosphere and taking flash samples on the west coast of Ireland. But all of this is there just to illustrate the Latourian way of seeing Gaia is really to reason outwards from the individual actors, be they microbes or humans, through the networks that they form, to trace the consequences of their actions, like the chemical consequences, the actual literal metabolic chemicals and such like that they're exchanging with the atmosphere or the soils or the ocean. And if you keep tracing those influences of life further and further, eventually it turns out you end up on the sort of global spatial scale of Gaia and the extraordinary time scale of billions of years when it comes to how long it's taken oxygen to build up into the atmosphere. But the Latourian perspective is to say, we need to see this thing and understand it from the bottom up. We can't just assert that there is some sort of global totalitarian Gaia, almost like a godlike figure that just exists and reason from there. The interesting thing, both to him as a philosopher and me as a scientist, is to see it see it, understand it, and try to rationalize it outwards from, as I've described, from the bottom up. And that has its own politics as well. And that was, of course, something Bruno was very, very passionate about. And this is kind of encapsulated in his enthusiasm for the critical zones research network of essentially biogeochemists and the like, who have these instrumented sites around the world where we try to understand how life is coupled to the geochemical cycles, to the weathering of rocks, to the water cycle, and everything, you know, in a place, and again extending outwards from that place. So yeah, I was honoured to be part of the Critical Zones exhibition that he convened, and I also learned through this process about some extraordinary work that Latour did with Alexandra Arlen, a kind of architecture student, who was able to do this visual inversion, if you haven't seen it already, and you have to watch an amazing video she has of how you do this, but she redrew our situation where you put us in the critical zone in the center of the diagram. Imagine the source of energy, the sun pouring down and powering everything, but then you go outwards through progressively longer timescales. You imagine yourself in the center here, you exchange gases rapidly with the atmosphere. You probably exchange some materials via what you eat and excrete with the soil. Then that couples on a longer time scale to the rocks in the weathering zone, which are then nestled on the continental crust. And then eventually, as we go outwards, we kind of counterintuitively come to the inner earth, the molten or interior of our planet. A wonderful kind of visual inversion, but also one in which, with the arrows, these authors trace the cycling of elements across time and space scales, essentially, but again, reasoning outwards from the actors through the networks towards Gaia. And yeah, Bruno and I, when we first met, got kind of, I think I brought to Bruno this crazy idea I had that there was something novel in the Earth system, or Gaia now, which was that for the first time ever, you had a species, us, that was collectively aware of the consequences of their action on the whole planet, and were busy monitoring and modeling of that. And some of us were actually changing our behavior because we concluded that our actions were affecting the planet in a really bad way for us and for future generations. And if we were doing that, we have a new kind of self-aware self-regulation, as we called it, in the system. Now, no one's pretending that that's the majority of humanity yet. And by the way, Bruno would still be chuckling at me now if he saw this disembodied brain in the diagram. He would say, that's crazy. You should replace that with maybe a bunch of people in conversation, by the way. But we kind of began to explore this provocation together. Could humans add a little bit of self-awareness to the Earth's self-regulation? Could we bring a new layer of feedback into Gaia? And so when Bruno saw this, he started asking the interesting questions. You know, if it's like this, who are the privileged humans playing the role of having their hand on the thermostat, metaphorically? What sort of consciousness could you expect of them? And maybe more practically, the thing we unpacked a bit together, which aspects of prior Gaia could we learn from and seek to replicate if we wanted to try and create a working or a better future in the form of a Gaia 2.0? And these feel to me blindingly obvious things to say, but not apparently obvious to everyone. So taking the Latourian view, we can hopefully agree that we're talking about a Gaia composed of networks of agents. These are some beautiful pictures of examples of the networks of pathogens and vertebrate species, or the mycorrhizal hyphae that connecting to a large seedling. But those networks of agents, to make a great 4 billion year long success story of life on the planet, have learned the lesson to be powered by the free energy from sunlight. So like in the form of cyanobacteria, the original oxygenic photosynthesizers powered by free energy from sunlight. And now as humans, we enter into a world where solar photovoltaic energy finally becomes, in many parts of the world today, the cheapest form of power generation, and is destined to dominate power production in our models by the middle of this century. So that sort of request is well underway, if you like, that we need to power civilization from renewables. But we also need to solve the problem of recycling all the materials we need to flourish. Instead of kind of digging stuff once out of the crust, using it and chucking it back into the atmosphere, the ocean or the land. And the figure here is just the fluxes of gases exchanged between the surface of the Earth and the atmosphere today, as compared to what we'd have coming out of volcanoes, in simple terms, without life. And it's just to illustrate that one of the key features of Gaia is this extraordinary recycling of all the materials that life needs. Because if life just tried to run on the meager influx of materials from the inner Earth, well, we wouldn't be here to talk about it. It would be an invisibly tiny and meager biosphere. So the whole thing is an extraordinary closed recycling system. And that's, to me, transparently, obviously, and to Bruno as well, I think, transparently, obviously, what we have to aspire to if we want a long and healthy future on the planet. We need to create what gets glibly called a circular economy, but there's a lot more to it than just those sort of assertions. And then there's the informational components. It's not just about, well, how should we relate to energy flows and materials, but what kind of information flows support a long and healthy flourishing on the planet? Well, we made the simple point that Gaia thrives on horizontal information exchange, be that, well, all sorts of forms, be that the literal horizontal exchange of DNA in the microbial realm, or be it the kind of structures of social information exchange in social insect colonies, which are quite, I would say, in the loosest sense, horizontal rather than vertical. Although there is some hierarchy in some social insect systems, the general lesson of resilience science is that the more resilient systems are the more what Bruno would call heterarchical, the ones that are built on not having a restrictive hierarchical flow of information, but having on a more egalitarian horizontal and heterarchical flow. And that there is some clue there for human flourishing. And of course, the biosphere kind of uses those principles to have created transformative change, to completely change the atmosphere, the climate and the rest. But you could also see the social movement around the climate and ecological crisis, and the efforts of different human groups to self-organize, be they cities or just members of the population, to try and create transformative positive change, as kind of having some echoes of how it goes in Gaia in the microbial realm. And of course, underneath it is this realization that reasoning from the bottom up, we can recognize that at some point the actors forming networks do start to create things that we can recognize later as new levels of organization, be they the first cells, be they the first complex multicellular organisms, or after that, the first social insect colonies with sort of non-living parts, or the first city-states. But it's kind of the open question, I guess. Is there another level of emergent organization involving us to be had? Well, we didn't pretend to answer that, but after we'd written that first short piece, it became obvious in conversation that what we needed to do was some more work underneath the board, as it were, or behind the scenes, to try to explain to people that there's a different view of nature here to the one that's coming from the kind of neo-Darwinian tradition of biology. And we need to also do an almost educational exercise to explain that different view of nature to everybody before, because otherwise you could fall into all the old tropes and traps of sociobiology and the rest, where it can be very undesirable to take lessons from, if you've got the wrong view of nature, for sure, it can be very undesirable to try and take social lessons from that a particular view of nature. So that's why we then went on to write something, or some one or two pieces, where we tried to look deeper into, okay, unpacking what is this alternative view of nature, what are its sort of political as well as philosophical implications. And also, it was Bruno that really twisted my arm to just lay out, why has it been so hard for different disciplines to appreciate or grapple with or understand this Gaia proposition, and that's what this paper was about. And suffice to say, we had many papers unfinished, one in particular. At the time, Bruno sadly passed away, so I'm still thinking with my historian of science friend Sebastian Dutriel here to maybe publish posthumously a piece that is rather beautiful that Bruno wrote and we were all debating together when he died. So thanks for listening. Miss you, Bruno and Jim. Both died last year, so tough year for me, folks. Thanks a lot.
It was not only very thoughtful, but very moving. And I do share regrets that you expressed in your presentation. Thank you, Adam. Are you going to follow up immediately, or could we have a few questions?
So I have some 15-20 minutes on how we can apply the theory, the actor network theory, and the ideas of Bruno Latour to climate history research. So it is connected, but it is a little bit of a different topic. So perhaps there are some immediate questions now, and I start in 10 minutes, and then we have a final discussion.
All right, so let's turn the floor to the other participants. Are there any immediate questions to Tim Lenton?
May I have a question? Marek?
Sure. Yes.
You showed the composition of Earth with and without life, and this was quite different. The question is, when life was arising on Earth, when the first organisms were created, did they make all the change?
Great.
With oxygen, for example, and
great question. Yeah, I've written a book about that subject because it's quite a long and interesting story. But essentially, it boils down to maybe three major revolutionary changes in Earth history, and in so short periods of turmoil and change that are interspersed by long periods of relative stability. And the first big puzzle life must have solved at the beginning was to close the material recycling loops to be able to flourish at all. But that's so shrouded in the myths of early Earth history that it's hard to be an empiricist about it. It's not impossible. There is some evidence, but that's now dated 4 to 3.5 billion years ago, really, really early on, some of it predating probably the first sedimentary rocks. This oxygenic photosynthesis is actually the beginning of the second revolution. To our best estimates, it's probably present about 3 billion years ago for the first time. There's then a long delay before it causes a major tipping point in the composition of the atmosphere around 2.5 billion years ago that's called the Great Oxidation, which is a kind of irreversible tipping point. But there's a later revolution, I call it the complexity revolution, which is somehow tied up with the rise of complex life, but we still don't fully understand the causal flows. Of course, lots goes on in between, but those are these kind of profound, they're contingent each on the previous one, and they profoundly change the composition of the atmosphere in a stepwise sense. If you talk about it in oxygen terms, from no oxygen to intermediate levels to the kind of levels that we can breathe, if you want to think of it simply. So yeah, I'll put a link in the chat to the book Andy Watson and I wrote about that, if you feel like the long read, and I'll put a link in the chat to the short book that introduces some of this. But yeah, this is something that I think Bruno was deeply interested in, the historicity of Gaia, as totally befit his philosophy, right? But weirdly, if you read the writings between Jim Lovelock and Lynn Margulis that have been recently published, you realize that Jim Lovelock initially wasn't at all interested in Earth history, and Lynn Margulis had to work really hard to get Lovelock to even begin to engage with the historicity, because Lovelock was always the empiricist and he wanted to just understand the thing as he could measure it and as was going on around him. And it's Lynn who knew the history and could have brought the historical dimension. And it's Lynn that edited Jim's second book, which is called The Ages of Gaia, which is where he actually fully engages with that kind of narrative I just quickly sketched out. Yeah.
Okay, thanks. Thank you. Thanks.
Thank you very much. Are there any other questions at the moment? I don't think so. So with that, let me turn the floor to Adam.
Can you see my slides? Okay, great. Thank you very much. And perhaps I should begin. I mean, my personal story is, of course, much shorter in this case, and I actually never had the opportunity to listen in person to Bruno Latour. I was very close to having this chance, and this is actually when I came across, as a historian, across his theories and his books, because this is not an obvious read for somebody coming from the discipline of history. This was in 2015 or 14, I think it was 15, in Versailles. There was a conference taking place every 2 years of environmental historians in Europe. And the French environmental historians put a lot of effort in inviting Bruno Latour to give a keynote that he had to cancel a month or so before the conference. So this, okay, there is this keynote speaker. So I started searching and reading his publications, and I've been following what he has been publishing ever since. And this is how I slowly started to get inspired by his theories, and I started thinking how this way of seeing society and the rest of the planet could be incorporated into the research on climate history. Part of that is also, and this is what my talk is about here, like what role his theories and the actor network theory more broadly has potentially to play in environmental history and climate history in particular. So my talk focuses on climate, but actually it applies the same way to epidemics or to any other topics in environmental history. So topics when you want to bring a human community into its broader non-human context. So the starting point is that every historical narrative, of course, has its implicit social, and when it deals with anything non-human, ecological theory. You cannot tell a story without some kind of notional framework. And of course, as a result, I mean, by necessity, climate and environmental history also has its own social ecological theory, and it has been spelled out. So there are debates, some papers that try to be explicit about that. And what you see at your left, if it's your left like my left, is a very popular scheme that you find in review papers or methodological papers in climate history. And I call it the impacts model. So you can find it in early publications of the Nestor of climate history, Christian Pfister, but you will even find it in very recent, if not the figure itself, this way of thinking as a kind of a basic model in very recent reviews published even a year ago of the field of climate history. And this impacts model, as I would describe it, it assumes linear transmission of some kind of primary climate effect. It is dominated by economic thinking, and it maintains a very clear division between the natural and the social. It perceives cultural phenomena as far removed from climate effects. So on this, sometimes on this scheme, you would get culture somewhere, but here you don't even get it. And in this way, because of this linear structure, it also limits what we could say about climate-society interaction in the past. And also it imposes very rigid requirements for what data you need to be in order to be able to follow this model. Yes, because if you want to go beyond climate, very immediate climate economic impacts, you need all the intermediaries in a way to get to culture, for instance. Yes, and you cannot do it with every historical period. In particular, if you move before the year 1500, when the rich historical documentation starts in Europe, in Eastern Asia, and later in the Americas. Yes, let us move to the second slide. And what I often try to present as an alternative in a small group of collaborators, we term it the outcomes approach. So to really think more about a whole configuration of stuff where something changes and we have an outcome. Yes, so instead of a linear impact, which kind of permeates through some hierarchical structure, we have this hierarchical structure, perhaps, yes, where something happens and you have an outcome. And this way of thinking comes from, I think it can be like in the debates that are now taking place among environmental historians, it draws on two big theoretical resources. One is actor network theory, and I will focus on that today. The other is the complex adaptive systems. So thinking about, you know, being able to have subsystems and then involving natural, social, having tipping points, phase transitions, looking at resilience of different systems and emergent systems, and defining collapse through these terms. So this is one option, and it's very promising. It often requires, again, relatively good, high quality, and ideally quantitative data. So this is also a challenging approach. And with the actor network theory, the very big advantage, the very big benefit of having it is to having network as actor. So instead of looking at like trying to single out individuals, yes, who have agency, you can start thinking about agency of a whole network. You can think of intermediaries and mediators. So elements of the network who remain stable and elements that change the way network works. And of course, these roles, let's say this agency changes over time, and you can also embrace hybridity. So both human and non-human elements of the participants, actors within the network, but also material and semiotic networks. So it really allows you to be much more comprehensive and to see more than you would see only with the linear approach. This is just an example of how I'm trying to apply it. So I try to build something which is both a network of major subsystems, let's say, of the Roman Empire in its ecological context, and the sources that we can use to study them. Yes, so for instance, for climate, we can use paleoclimate data. For economic processes, we have archaeology, texts, and coinage. For pathogens, we would have genetic data, ancient DNA, written in archaeological sources, and so on. So you can start conceptualizing it in different ways and thinking about how things are connected. And then, of course, it also opens up possibilities of applying different numerical techniques. Yes, you can apply, for instance, Bayesian networks to something like that and start quantifying, if you have good enough data, of course, perhaps not for the Roman Empire, perhaps for, I don't know, 16th century Europe. But you can really try to approach that also with really interesting numerical tools. I will now give two examples. I will spend a little bit more time on the first one, which looks at late antique Italy. So basically 6th century, fall of Rome and this kind of stuff. It's a paper that we published in 2021, a collaboration of ancient historians and paleoclimatologists. And it looks at the connection between winter rainfall and religious narratives. So it's really a situation when we have outcome. And we began actually by trying to trace the impact. So we had to, because we couldn't, we had to change our model, our theoretical framework to be able to make use of very good data that our colleagues in paleoclimatology, our Italian colleagues produced. And this is actually the only publication, I think, where I very directly refer to Bruno Latour and his theories. And there is like a whole section here about networked agency. So, and you can see in the title that we are really making a strong statement that we want to move beyond this linear, one-way deterministic model. So the paleoclimate data that inspired this paper, it was a study of a speleothem in a cave in Tuscany, done by Giovanni Zanchetta and his team of collaborators. So it was used to, of course, you have like all the dating involved with confidence intervals. So the three top sections are related to the dating, and the bottom panel is the stable isotope data, trying to show the chronological uncertainties. So the maximum, let's say the earliest and the latest for each peak. And what is most interesting here is this peak. This happens in the 6th century, in the second, if let's say, according to the Izdebski model, if you don't take the uncertainties into account, this would be the second half of the 6th century, so some 100 years after the fall of the Western Roman Empire. But during the time, Italy was still, let's say, a Roman realm. It was ruled by a barbarian king, but there was still a lot of continuity. It was really in the second half of the 6th century that we have decomposition of the Roman order. And it's a very interesting time. A lot is happening. There is really very intense development of Christian culture, consolidation of the church, change in the elites. So we thought, okay, what is the role that this very huge increase in the rainfall that we see in our cave, in our speleothem record, played in this situation? And we searched a lot, like we basically, three ancient historians, Kevin Bloomfield, Robert Wiśniewski, and me, we searched all available evidence for Italy at the time. And the only thing we found were actually some strange miracles related to water and rainfall in the dialogues of Gregory the Great. It's basically a collection of miracles of Italian saints written around the year 600. So it would be more or less right after this extreme, let's say, decade of rainfall or something like that. It could be interpreted this way, the record, the paleoclimate record. And what we have there is really new types of miracles. We were able, thanks to the project that Robert Wiśniewski was co-directing at the time, we were able to compare that with all miracles from all Christian texts up to this point. So we were able to see that there is something new. They're writing they are telling new type of miracles that is clearly, that are clearly related to very peculiar hydrological conditions, torrential rain, new springs and floods. And the miracles were both much more frequent than in anything previously or anything contemporaneous. For instance, we compare that with miracle collections from France, so from Gaul, historically speaking, and also the frequency of the interest in the water was much higher than in any other text. Yeah? So both the type and the intensity, the frequency of interest was much higher. So we came to this model and this figure where we try to show that, okay, you have the whole social cultural context into which the climate event is coming. And the agency of this climate event is actually dependent on the context into which it enters. Yes, this is how we phrase it in this figure. Yes, so we have this whole dynamic of social change, war damage taking place at the time, crisis of the old elites, Christian worldview that was spreading and consolidating, and how the performance of miracles in the literary text fitted into that and also strengthened the new Christian elites. Now, if I were to create a figure for this paper, and I was thinking about it today, I would make it even more a network, to really think that we have this network and connections between different actors. And then one of them is starting, and this is this ping arrow, yes, that it is pulled up in a way, yes, it goes up, there is some strange new behavior, and it impacts on the other connections and kind of pulls the strings, yes, cult of saints, social power, and these changes from intermediaries, from mediators, sorry, are distributed within the network. So this was really an attempt at a very explicit application of the actor network theory to climate history. The second example that I want to give you, it's more implicit. This is our recent study of the Black Death and its demographic impact on Europe, in which we didn't use the historical evidence that historians normally would use, but we used paleoecological data. So we looked at how landscape changed to say something about how many people continued to live in a place. So the systems thinking or network thinking is here the background, the foundation on which we could build the connections between, you know, seemingly disconnected phenomena. Yes, so this is a figure from the paper, and it's actually sort of a network. It's more linear or one-directional here because it goes from the pathogen to the landscape. But of course, if you wanted to make it a real network, there would be a lot of feedback loops and connections. Yes, but this really allows us to go from a pathogen, a bacteria that appears in a new place, yes, in a new human community, it can have, depending on the context, yes, on a whole range of ecological, social, cultural, political, economic factors, it can result in high or low mortality, and then this results in different landscape dynamics. And this allowed us, by collecting data from more than 200 sites in Europe, to draw a map that was able to show the heterogeneous impacts of, or let's say the different stories, the different experience of the Black Death in Europe. Yes, places where nothing, you know, no big change in human population was most likely, and places where, as you know, as we know from the myth of the Black Death, from the standard narrative, it's clear that there was mass mortality between 30 and 50%, to the at least mass mortality to the extent that they were no longer able to sustain the same type of heavily anthropogenic landscape. So just some concluding thoughts here. So as you see, I tried to show you how both me and several other friends and collaborators in climate history and environmental history, how we are trying to bring network thinking inspired by Latour into our field. So the first statement again is that every study of the past requires theory. You can have professional theory, or you can have like kind of popular implicit theory, but you always have it in your head, yes? Even if we do not spell it out, we have it and use it. And the actor network theory, so the legacy of Bruno Latour, can provide, on the one hand, sufficiently loose theoretical underpinnings, sufficiently loose for flexible and hybrid historical narratives. This is also important here, that it's not the kind of a very rigid natural science theory, but it's more a way of thinking, a toolbox with notions and concepts that we can apply and improve our way of imagining the past and telling stories about it. So this is basically the next sentence, yes, that it is some sort of, perhaps compared to the complex adaptive systems theory, it's more of a qualitative toolkit, whereas the other one is more quantitative or mechanistic approach. And I would say that both are actually complementary when studying the past. Thank you.
Thank you very much, Adam. Wonderful talk. I fully concur with Tim.
Thank you.
Okay, so let me open the question time for Adam first. Any questions to Adam, please? Is the right time?
Can I have a question?
Yes, please.
Adam, my question is, you showed this map of Europe, and there were increases and decreases of populations. Do they make any like holistic picture? Because there were, you know, there were regions are they somehow associated? Are there consequences of this data? It's because I see that they're not completely random, those regions. And did you make any sense of it? Did you?
We tried. We have a whole section in the publication where we try to make sense of it. It is definitely related to grain trade. This is one thing, and especially in the Mediterranean. It is related probably, it is really very complex, because
Yes.
you can also think of, okay, what is the local rodent population? Like, what are, you know, the vectors of the bacterium, and what vectors are available when a ship, you know, when a ship with grain is arriving somewhere, yes, or where, you know, there are with grain or with whatever, yes, how, when it's spread, what is the season, because it would matter if you have spring or winter. So I think that there is a lot of chance factors in a sense. There seem to be some core connected regions that couldn't escape the impact, but I think for the rest, it could be contingent on several factors that could work together, or just a single one worked. And you know, we try to look, okay, is it east-west gradient? No. North-south? No. Does it have to do with trade networks? And this explains everything. No. Does it have to do with core and periphery? No, because you have southern Sweden and Poland, yes, both peripheries, but different trajectories. So you can, I think what you can do is you can find explanation for each regional story, but it's very difficult to arrive at a single of some simple explanation at the continental level. We applied for a synergy grant to explain that, and we are waiting for the results. So where we would really comprehensively study every possible aspect and apply Bayesian networks at the end to the data that we collected.
Thank you. Thanks.
Thank you. We'll keep fingers crossed for the success of your grant application in the first place. Professor Marciniak has raised hand. Please do.
Thank you. Hi, good afternoon, and thank you for the great talk. And I just sort of want to refer to your last point about diseases and pandemics, which is, you know, increasingly more popular topic in history and particularly archaeology. And it is very easy to place this kind of issues into this impact model. But how could you sort of elaborate, or how do you want to see this, you know, big integrated into this outcomes model or approach that you are advocating? Thank you.
Thank you. So let us think in this way, because usually when we think about infectious disease, we have some, especially when we think about Yersinia pestis, yes, so the plague, it has some reservoirs. They could be in Europe. There is good research suggesting that after the Black Death, there was a reservoir near Frankfurt Main, so in central Western Germany. So, but for the rest of Europe, this would be each time kind of a novel introduction, and that maybe not a novel, but yes, a repeated introduction, and then it dies out in the area. Perhaps it establishes new reservoirs. There is a lot of ongoing research into that. So let's think of it as coming into a new introduction. Yes. So how the bacterium will, whether it will be successful or not in spreading, depends on what vectors are available and how it would start spreading. So whether it can, you know, how many domestic commensal rodents you have, how many sylvatic rodents you have, you know, what people were, yes? So whether they would have a lot of lice or not, yes? Because perhaps there is, it's one of hypotheses, but it's not really confirmed empirically, but perhaps they could spread, you know, from a human to a human through ectoparasites, yes? So there is, and then, okay, a lot depends on, if it depends on the clothing, yes? Then if it's like late fall, it's different than when it's late spring, because people would wear more stuff and they would be more indoors. So there is a whole cultural, political, economic, ecological context that is interconnected and you kind of insert this new actor into this whole context. So it's different than climate, because climate, in a sense, you always have it, yes, when you think about the network agency of climate. So you have this actor always, yes, and it's just the changing behavior. So in terms of actor network theory, it would be a change from being an intermediary who is stable in its behavior to a mediator who is doing something new and having impact on, you know, kind of transforming the network. But if you think about pathogens and infectious disease, it really comes to a whole system, whole network, and, you know, the network has to readjust, but also depending on the state of the network, it might just, you know, kind of be an ignored participant or just wouldn't be able to plug into a network, which I think is, we tend to think is what happened in Poland, that there was some, and like the Eastern Baltic area, that there were some structural, ecological, and cultural reasons for which, and economic reasons for which it just kind of didn't work out.
All right, so thanks. And how do you then envision sort of modeling this relation? You can enter as many agents as possible and build up this kind of network, but how does it translate into, I don't know, kind of the outcome, you know, of that network into, let's say, some dependencies or some changes or some transformations in a kind of long term or longer term?
Yes, this is a difficult question. We are not there yet, I would say. Technically, in my institute, we have a very clever archaeologist and physicist, Ricardo Fernandez, who is working on a number of Bayesian tools that we are applying to historical data. So we already have a very good tool that we tested, and we are about to publish some papers that does an algorithm doing a lot of testing a lot of regression models, but it's still more linear, and you have one dependent variable at the end. What we are also, so Ricardo is working on, and then we hope to have enough historical data to test it would be a hierarchy of dependent and independent variables, so Bayesian networks. And this is what we hope to apply at some point. It would still be more linear, like it would still have kind of direction in itself of some sort. But it would be a step forward, and you can also choose different dependent variables. So to test different models, different, let's say, different measures of the outcome. But if anyone has any ideas how this could be done, we are very happy to try new ways. And there are, let's say, historical and geographical contexts for which we have very, very rich data of all kinds. So to test such things.
Yeah, perfect. Thank you. Very inspiring. Hopefully we can be able to talk about it later. So thank you. Good luck. Thanks.
Thank you very much.
Thank you so much. And Professor Ewa Domańska, please.
Yes, thank you so much. You know, Adam, that I am a great fan of your research.
Thank you.
So my question is about the method, because Bruno Latour sometimes is affiliated with so-called post-qualitative research. And of course, there are a lot of controversials about, you know, how post-qualitative research make the idea of a method somehow melted, right? So I wonder what do you think about possibility of bridging these different methods like Bruno Latour and Manuel de Landa on the one hand, and on the other, you are also using very, very hardcore natural sciences methodology. You are talking about big data and models. So, you know, I am very excited as somebody who is working on the methodology of the human sciences, how as somebody who is practicing actually this research, how you see the potentiality to bridge them. Thank you.
Yes, so thank you very much, and thank you very much for your kind words.
Adam, just let me just briefly interrupt you. If I may also direct this question to Tim, because this is very relevant to Gaia as well, all right? Later on, after your response, of course.
Yes, okay.
Yes,
so I will just come back to the example from Italy. I would say that there is a role to play for a theory of the actor network theory, and there is a role to be played by, let's say, empirical data that we produce and for which we approximate some phenomena in the past. So in a way, actor network theory and this way of thinking about humans and their environment provides us the glue between different empirical data sets. Yes, so these empirical data sets in a way inform us about the behavior of the actors in the past, in my research at least, and then we need to connect it somehow. Yes, and you can just have the linear model, relatively simple, but you can think about different ways of doing this, and this is where a theory like this one becomes helpful. So it's in some way eclectic what we do, yes, because we both take, we integrate together something that is, as you said, hardcore empirical research with a way of thinking that allows us to reveal and demonstrate the connections. But then these connections, you can, if you have empirical data that are numbers, or even you can, create some categorical data for presence, absence, for legal regimes, cultures, like you can also encode cultural phenomena, then it in a way invites mathematics to play with it as well. So in many ways, it's like multi-layered, eclectic activity. So in this way, perhaps it's quite postmodern by connecting all these different approaches.
Yeah, thank you so much. I think that I will promote an idea that post-qualitative research is absolutely necessary to apply hard-coded methods and algorithms and so on. Well, perhaps I would suggest to think in terms of hybrid methodology, because, this idea of hybrid methodology is already somehow conceptualized, yes. And this would be, it would add, more content to this idea. Thank you so much.
Thank you.
Tim?
Yeah, I've forgotten exactly what the question was, but I can definitely comment on hybrid methods. Because I kind of come from a school of, if we can get some quantitative data, we'll work with it. And we also do, a mix of epistemologies, I think, but we like to build models to try to understand phenomenology, but we use them in different ways anyway. Sometimes we are using our ability to simulate something that resembles life or living processes in a computer to allow us to get beyond like a sample size of one problem that we have with Earth history. So I don't know how I've studied philosophy of science back in the day in Cambridge, but I wouldn't claim I would be the best person to explain how to orientate this in a philosophy of science perspective. But I would say that we use methods where we're running many instances of virtual biospheres in a computer to try to understand the possible distribution of outcomes of life on a planet. And then we also have the n=1 case of the Earth, where we want to be able to use models to incarnate mechanistic hypotheses and then see if they can make predictions that are discernible with the limited data at our disposal. The further we go back into Earth history, obviously, generally the harder that gets. But it does turn out that you can make some discriminations. You can falsify some hypotheses with that approach and stagger towards a sort of a quasi-mechanistic understanding of how the Earth system works and the relationship between life and the rest of the system. But of course, I'm very sympathetic to a pretty blended approach of the qualitative and the quantitative. And even from a mathematical perspective, we know how to do like qualitative differential equations and still learn something constructive about system dynamics. It doesn't get very widely used, but I think there's the good news is there's a lot of methodological plurality available, and I would personally I try to indulge in like a bit of that, as much of that as my brain can cope with. There's always room for a bit more, but I think we're in a generally productive direction of travel because what we're seeing is this rise of, broadly speaking, data science and an appreciation, because the world is convulsing around us with a pandemic, a financial crash before that, a shock war on European soil, and so on and so forth. Everybody's switched on to like nonlinear change and complex systems and needing to understand feedback. So what appeared very stable paradigms, like a mainstream neoclassical economic paradigm, suddenly looks a lot shakier because it's just been so manifestly useless in either predicting the 2007-8 crash or predicting the energy transformation and revolution that's underway. So what I'm trying to say is we're in a good space to be having this conversation and to talk about increased plurality of what are perceived valid methods, I think, in wrestling with complex systems. And in Adam's language, I'm a bit of active network theory, and I'm quite a lot of complex adaptive systems, but I'm comfortable, like you showed on your plot, Adam, at the start, I'm very comfortable trying to work with both to just give sometimes just to give different perspective or angles on the same phenomenology, basically. Yeah. I'm not sure. I'm like an island of one though, so I'm not sure I can speak for a wider field particularly. Yeah, but I think what's really interesting is the stuff we're both talking about, which is where like hardcore quant people like me are actually very happy and most excited when we're like hanging out with a philosopher stroke sociologist stroke something else like Bruno Latour and kind of having qualitative theorizing together. That nothing could have been more fun, I can tell you.
Okay, can I have a follow-up question to you? As you know well, the Gaia concept was not very much welcomed by a big part of natural scientists because they accused it for being purposefulness and the theology of this concept. So do you think that actor theory network adds to this discussion and to some extent excuses the Gaia concept from being accused for being essentially non-scientific concept?
I think Latour's thinking more broadly definitely helps in this respect. So the short answer would be a yes, but it's because the people who've thought about it hard, including Latour, basically, this is quite complex territory now and not my specialist subject, but essentially, how can I put this? Well, if Bruno were here, he would sort of say, look, there's a willfulness in life, whether it's a microbe or it's you and I with consciousness. So there is a purpose. It depends what you mean by purposive, but there's a purposiveness that's innate to the phenomenon of being alive, he would sort of say at one level. He would also say we delude ourselves to think that that consciousness is so super special. He was a firm believer in the idea that it's not exactly an illusion, but that all the neuroscience of late shows that we have going on inside our heads and in our brains. We have a lot of stuff getting generated, and then we have a big filter, and out of that comes something that kind of is what we experience as consciousness. But that literal neuroscience understanding of how our thinking works starts to resemble a lot more closely some of the other complex phenomena and evolutionary phenomena that I'm interested in Gaia and Latour was interested in. So in our conversations, we would often find a much more common ground, shall we say, and there was much less philosophical reason to sort of make this dualistic separation anyway and start getting over-exercised about ideas of, you know, purposiveness belonging to some sacred subset of living things. Because after all, Latour is kind of philosophically, along with Lovelock, I think, trying to break down those boundaries and give us back a bit of humility that, okay, we have some unusual qualities as a species, but we are just another species, as Lovelock would have put it at some level. And we do tend to kind of, still in this Judeo-Christian tradition, we always want to keep putting ourselves on a pedestal as the sort of pinnacle of the ladder of life, or whatever you want to think of it as. But both of them, and myself included, are philosophically against that view. So yeah, it's a bit of an obtuse answer, but I personally think that whole debate with the evolutionary hardcore neo-Darwinian evolutionary biologists, at step one, they're a bunch of people who are very bright in some respects, but know absolutely nothing about the basics of cybernetics and complex systems, with a few notable exceptions, like John Maynard Smith, who trained as an aircraft engineer. So he had a much better understanding of how a Gaia could work, because he had a particular, you know, mental toolkit he'd grown up with. So he was never going to assert that this was a teleological phenomena, because he well knew, he'd had the training to understand that self-regulation can happen automatically in all kinds of systems. And it's okay, engineered systems have a designer, that's a separate special case. But really, this was just one of those idiosyncrasies of the kind of horrible factioning of science that Lovelock rallied against all his life, that you could have a bunch of biologists get on their high horse and make a kind of crazy accusation about a hypothesis, because they're just, at some level, they're ignorant, frankly, of some basics, for what would be described as basics in other areas of science. And that's just my blunt opinion.
Thank you so much. John Maynard Smith was an engineer by training, as far as I remember.
He was, exactly, an aircraft engineer.
It helped. Yeah. Okay, any other questions, please? If not, thank you very much, you both. It was really wonderful. Ewa Domańska, yes, Professor Ewa, yes.
Yes, if I can, I'm sorry, but I can't resist to ask the question to Professor Lenton. There is an article that you wrote together with Bruno Latour. It was published in Critical Inquiry, and it was about Gaia. And my question is about the paragraph in which you say that this is not only that we are observing right now a paradigm change, it's just a change of a worldview. So that you compare to what happened during the time of Galileo Galilei. So I have to say that when I discussed this article with students, these PhD students, this is the idea that they really want to go into. Since, well, you know, paradigm change is one thing, or paradigm shift, but the change of the worldview is another. So could you please comment on perhaps, you know, how it happened that you get together with this idea with Professor Latour?
Well, we probably both had that conclusion independently, but it must be one of the things that made us friends as well. I'd come to that conclusion for myself, but I'd come to it from growing up with Jim Lovelock, growing up in the sense of, I met him when I was 19, and I was really excited by his ideas, and I knew they were the thing I wanted to work on, and that was the 1990s, and there was this sort of back end of this crazy argument with the biologists going on, and it just became obvious as I was a young man looking at this stuff that really Lovelock had a fundamentally different view of the world, and if we fully took it on board, as he put it, he says it something like, in Gaia we're just part of, or partners in, a very democratic entity, and we actually use his quote at the start of that article. It was not just a intellectual realization, to be honest. It was also something that felt like it made sense on other levels to me, even when I was a young and person. Latour, Bruno, I think it was self-evident to him as he started to get interested in this that it was a fundamental shift of worldview against what he would have just broadly labeled part of the modernist program. So yeah, we immediately agreed on that. And so it was quite natural to try to write together about not only articulating how this worldview was different, but also what would be the sort of implications of that, both politically as well as philosophically, although it's dangerous to stray too far into political territory. And that's kind of what that article is about. But it was Bruno who developed the thought. Do you know that he took Brecht's play on Life of Galileo and reworked it with his long-standing collaborator from Sciences Po into effectively Life of Lovelock, but I don't think they called it that. And I saw the play performed where an actor plays the role of Bruno himself, although Bruno was in the audience then. But yeah, basically, Bruno is the one who had the brilliance to see that you could rework the Galilean story into the Lovelockian story to make the parallel clear and make it actually a watchable piece of theatre. So if you're not aware of that or you never got to see it, I'm just hoping that someone recorded one of the performances, but it could still be performed, right? Because by the time Bruno died, that piece of theatre had an actor playing Bruno anyway, and his long-standing collaborator is still alive and well. So yeah, I've gone off topic a bit, but I'm glad your students are as impassioned about this as I was when I was younger, because I honestly believe that this is the shift in worldview that we kind of need to get out of the deep trouble we're in now, vis-a-vis the climate and our relationship with other living things, and the kind of how can I put it? The sort of the profound pathological dysfunction of our current kind of economic system, or whatever you want to call it, religion, I'm going to call it, of GDP growth, or whatever you want to call it. And, deregulate the markets, let them have free reign, that kind of madness. It's the path to madness and destruction. And it is the logical consequence of a modernist program that's 400 odd years old, but not one we need to snap out of quickly, in my personal view. Yeah.
Mm-hmm. Thank you so much. I have to say that this was a very crucial article also for indigenous students. I don't want to occupy the discussion because I know that there are more questions, but I would love to know if you see the possibility in this idea of indigenizing the academy and indigenizing our thoughts, because this is exactly what I feel that the inspirations are coming from, and also possibilities and the potentialities, and I was really very interested how these students get into this article and said, this is what we need, right? You give them, this is a very empowering articles for us. So thank you so much for
Let's
that.
Let's follow up. I'm so pleased to hear that.
Thank you, Adam.
Yes, I wanted to follow up on one thing that Tim said, but I also want to follow up on what Professor Domańska just said. So it's really, so for me personally, this is also like the idea, the concept of Gaia is also something that helps me a lot to think about my place, my own place in the world, both as a scientist and just as a being, as a living being. And when you mention these indigenous perspectives, it's very interesting. I just want to kind of flag that there is a very good archaeological book, The Dawn of Everything. At the moment, I forgot the names, like very good anthropologists. Basically the title is The Dawn of Everything, and I don't want to confuse their names. And they look a lot into human interactions with the environment, and they, like, a very important piece of inspiration that kind of permeates the entire book is actually indigenous North American political philosophy that we know through the writings of French Jesuits and so on. Yes, thank you very much. So, and this is also going in this direction. We could say, I mean, it's, I don't want to conflate everything together. Yes, there are important differences, but perhaps in some way this worldview of interconnectedness, yes, it is present there to a large extent. So there is some kind of critical mass that we are perhaps slowly approaching and in changing the way of thinking. And this perhaps it's a good lead to my question to Tim. When you say about this is something that as a historian, I always, an ancient historian in particular, I have a strong reaction to when people say that it's, you know, relatively recent, the roots of our problem, yes, this cult of GDP or capitalism. So even here, we had a very, like at the conference we had a very good, very inspiring talk about megafauna extinction. And you know, you can start asking yourself, okay, it's so completely changed landscape that you stopped having large herbivores. Yes, some 20,000, like in some places much longer ago. So, like, is it really only about, like, I'm just interested in your take.
You're right.
Is it just recent, or there is something very basic about, you know, our species that we have to really rethink and kind of re-engineer in ourselves to get out of the mess that we ended in after 80,000 years?
I think I'd have to agree with you, Adam. Yeah, I mean, I have a paper that's in review at the moment, which is basically trying to put a sort of positive or reinforcing feedback perspective on the major kind of human revolutions, the taming of fire, the agricultural Neolithic revolution, and then the rise and fall of civilizations, and then the Industrial Revolution. And you can see in each case how somehow our peculiarities as an innovative species interact with reinforcing feedback loops to sometimes create quite irreversible changes, and how our kind of propensity to completely transform the social ecological system we're in is very ancient. Yeah, I guess the only thing with the modern growth regime, as the long-term economic growth people describe it, is we're out of what they call the Malthusian trap now. We've only, with the Industrial Revolution, been able to escape that profound damping feedback that if we suddenly innovate and boost productivity, we used to just dilute that by having more kids, essentially. And something still not widely agreed upon, but something describes how a fraction of humanity, a richer fraction, went through this Industrial Revolution and then demographic shift into a world where, as we get more bounty, we decide actually we'll have less kids and invest more in the less kids that we have, and that brings the level of education and innovation up and allows the thing to self-perpetuate. What more can I say? Yeah, so the roots are very deep, but it gets really pathological when finally that transition happens, and then ideologically we become very wedded to and comfortable with the product of that transition and seek to spread it around the world as a kind of monoculturing, because if it isn't, if it's, you know, it's just back to the old argument about at some point that can't work. You can't have indefinite growth with no consideration for your life support system when you're on a finite planet. But yeah, you're right. There's a deep root. There are no doubt deep roots to this, and God knows then. I mean, I think Bruno, if he was here, would remind us to be kind of pragmatists. He was quite a fan of Dewey and others in the particular philosophical tradition. I think he wouldn't seek to believe that we're going to become perfect in any sense of the word. He would have encouraged us to remember that we're always going to be fallible, but what can we do constructively, working with our fallibilities to get to a better place of flourishing where we don't lose some wonderful things. Yeah, I don't know how to put it really. It's hard to channel him now. Yeah.
Thank you very much.
All right, thank you. And if there is no more, or maybe there are some other comments or questions. If not, thank you again for a wonderful presentations and for a really lovely discussion. And this was a fantastic contribution for the benefit of all of us, but first and foremost, to pay the tribute to Bruno Latour's incredible legacy. Thank you all for the participation, and to the next meeting. Thank you very much.
Thank you very much. Bye-bye.
Yeah, thanks everyone.
Bye, thanks.